Last time, we went through a rather diligent derivation of finding the elements or deriving the elements, coefficients that allow us to find solutions of a parabolic vertical curve. So if the parabolic curve, just as review, is if we're given a point P on a curve, then the elevation of that point, or y of P, is equal to the elevation of our BVC or PVC, interchangeable notation, plus, so PVC is point of vertical curvature, where BVC is beginning of vertical curve. It's the same thing. You'll see them used interchangeably. So the elevation of that beginning of our curve, plus the incoming gradient times the x value of our point, plus this long thing that we derived last time, times the x value of our point squared. Okay? So just a note real quick. We can work in either of two environments when we're solving these problems. The book often uses station notation, which is one environment. And that is the notation that's used, or the method that's used in the example I posted on Canvas. So I want to use a different notation, but let me first walk through what the difference is. So if you're going to work in stations, stations being like 98 plus 27.32, that's a station. If you want to stay working in stations, then you can keep your incoming and outgoing gradients, your G1, G2, in percentage notation. So say 3.2% and negative 2.8%. Just realize that all of the numbers you come up with while working in this environment are going to be in station notation, where the decimal place will fall under where the plus sign would go. Okay? I find that more awkward. I find it a bit cumbersome to remember that when I get to the end, if my solution is 98.2732, oh, that's actually 9827.32. Contrarily, we can work with distances all the way throughout, and then where necessary, we can report a solution in stations very easily. So remember that stations are just distances. So the distance format of this 98 plus 27.32, the distance notation of that is just 9827.32, 9,827.32. If you want to stay working in just regular number notation and then report in stations where necessary at the end, it's much easier to keep track of where you are. So in this case, you would start out in the very beginning by changing your G1 and G2 to decimals. So 3.2% would be in decimal form 0.032. We just move the decimal over 2 spaces. And G2 would be minus 0.028. So I do that in the very beginning. I'm going to work this example that way so you can see it in practice. And just a fair warning, as I walk through this, I'm going to derive using some calculus. And if you have not had calculus, I'm just using just really simple calculus, and I'll explain it as I go, but don't worry about it if you don't understand derivatives. I'm going to derive the equation we'll use for the high and low point, and then you won't have to use calculus. So let me pull up my diagram here so I can, that's my super neat diagram drawn with straight edge and drafting compass, and which you're going to do on homework. And let's erase that. Let's lay out a problem. Okay, so say we're given a parabolic curve, vertical curve, and we are given G1 equals 3%. So we have a positive incoming grade, that means uphill, and G2 is equal to negative 2%, or a downhill grade. L, or the length of our curve, is equal to 950 feet. We're also given that the station of the PVC, or the beginning of the curve, is at 93 plus 82.16. The elevation of that station, of the point at that station, so elevation of the PVC, the beginning of the curve, is 41.76 feet. So pretty low, probably somewhere at the coast. And then the last thing we're given is the station of the PVT, or the EVC, just notation, same thing. So these are often used interchangeably. I want you to get used to, you should probably get used to both of them. I could easily say station EVC here. That equals 103 plus 32, so this is stations, 32.16. Okay. So I could go through and label this. I don't want to take too much time. Whoops. 3%, negative 2%, L equals 950. This is what you do on your paper. PVC, the station of the PVC or BVC is at 93 plus 82.16. The elevation there equals 41.76, and the station PVT is at 103 plus 32.16. Okay, so I've written down my givens and I've labeled my sketch, so let's get into working the problem. So the first thing I'm asked is find the elevation at station 100 plus 00. Okay. So the first thing I'm going to do is I'm going to write down my G1 and my G2 in decimals. So 0.03, because that was 3%, and negative 0.02, because that was 2%. And then I want to write down the equation I'm going to use so I can see what is it that I know and what am I going to have to figure out a solution to. So the elevation of station 100 plus 00 equals, lost track already, the elevation of our beginning of curve plus our incoming grade times the x component of 100 plus 00 plus our G2 minus G1 over 2L times that x value at 100 plus 00 squared. That's our equation. So when we go to plug in our grades for G1, G2, G1, this is where you want to use the decimal form if you want to work in distances. Okay. So what do we have? We were given the Y of PVC, we were given G1, we were given G2, and we were given L. Okay, we have everything, except we need this to find our solution. So how do we find that? Well, remember that if we have a curve, here's our PVC, and then say here's the high point on our curve, that's the max, then X is this distance here. So that's what we need to find in order to solve. But remember, we already have a station here, right? This is station 100. I'm sorry, this is not the max of our curve. This is just the elevation of station 100 plus 0, 0. So station 100 plus 0, 0 is equivalent to 10,000 in distances, right? So X equals station PVC, sorry, backwards. Station 100 plus 0, 0, so right here, minus station PVC. That gives us this distance X. So that equals our station PVC, or our station at 100 plus 0, 0, which is 100, or 10,000, right? Minus our distance of station PVC, which is 9382.16. And that gives us an X value of, if we do that subtraction, we get 617.84 feet. Okay? And so now we have our X values, and we have everything we need to solve the curve. So next I'm just going to plug that in. I'll try to keep that up there. I'm going to plug that into our curve equation. So the elevation, which is the first thing we have, I'm going to switch back to yellow. It's a little less obnoxious. So y 100 plus 0, 0 equals the station of the PVC, which we were given as 9382. Notice I'm switching into that, just that distance notation. Easier to think of the math. Plus G1, which is 0.03, or 3% in that notation, in regular decimal notation, times the X, our X component here, which we just figured out was 617.84, plus G2, which was the negative 0.02, minus G1, which was our 0.03, over 2L, 2, and L we were given was 950. And that's times our X value, which was the 617.84 squared. So all I did was plug in our givens and what we derived for our X component, that distance from station 100 plus 0, 0 to the PVC. And so now I just do that math. I plug it into my calculator, and if I do, I get y of our station equals 50.25 feet. That's the elevation at station 100 plus 0, 0. Pretty easy, just some basic algebra. Now let's see if it makes sense. Something you always want to do is say, does my answer make sense? Well, let's see. I have an uphill incoming curve. I'm going, about over to here maybe. Let's see. 100%. So it's uphill of the PVC, and 50.25 elevation is greater than the elevation of our PVC, which was, what was it? 41.76. So yeah, that makes sense. Okay. So we have part one. Part two asks us to find the high point or the low point on the curve. Well, the example on Canvas I noticed was a little poor in its wording. It led me to believe you wanted to find the elevation of the high point on the curve, and then it reports the station of where that high point occurs. So here's where the little bit of calculus comes in. If I have a curve, we have it's uphill, uphill. If these are tangent to the curve, uphill, uphill, uphill. But just before it turns to go downhill, we have a completely horizontal line. And the slope of a completely horizontal line is 0, right? Because we have a positive slope, positive slope, positive slope, then a negative slope, negative slope, negative slope. The only way we can go from positive to negative is if we pass through 0. And 0 is where the high point or the low point of any curve occurs. The high-low is always at slope of tangent equal to 0. Okay, that's pretty basic. That makes sense. So how do we find where that high point or low point equals 0? So to find out where the max min occurs, where the first derivative of our function equals 0. So find first derivative, this is the process, and set to 0. And if you don't know the words derivative, if you're not familiar with function, just kind of follow through. You don't have to completely understand this if you haven't had calculus. So find first and set to 0. So what is our function? Well, our function is y equals y PVC. Sorry, it's just the function, not the result. So our function is y PVC plus g1x plus g2 minus g1 over 2l x squared. So find the first derivative. And set it to 0. That's what that statement means in math lingo. Okay? So if we find the first derivative and set it equal to 0, well, let's see. Y PVC goes away. So we have the coefficient g1 plus the 2 comes down. So we have plus 2 times g2 minus g1 over 2l times x, and that equals 0. And if we simplify this, I'm not going to drag you through the algebra. It's pretty simple. We have and then we solve for x. So let's see, we have x equals minus g1l over g2 minus g1. Okay, all I did was solve for x there. And I can simplify that just a little bit. I can say that that equals g1l over g1 minus g2. Okay, all I did was move the negative to the bottom and then perform the operation. So if you don't understand calculus, you're going to want to write this down, because this is where that first derivative equals 0 is, where x equals that. So then this is the value of x where the max or min of a curve occurs. So we don't know yet what the elevation of that maximum is in our example, or a minimum in another problem maybe, but we know the x that will get us there, or we know how to get the x. So we know all these. We have L, we have G1, and we have G2. So all we have to do is perform that, plug in those values that we know, and find what x value gives us the high point or low point. So if we do that, we have, I'm just going to plug those numbers here. 0.03 times 950 over 0.03 minus negative 0.02. Notice that I don't have to worry about, am I in stations or am I in distances? Just keep it all the same, and I really suggest that once you pick an environment, you stay with that environment always. So I just go through that math and I get x equals 570. Okay, so what does that mean? I'm going to draw a little picture here for you. What does it mean that x equals 570? Okay, well, if we have a curve, and just say this is our PVC, and we have a station of the PVC, and say our high point occurs here, and I keep using high point. I should switch it up and do a low point because it all works the same. Well, remember, our x value is this horizontal distance here. So if we wanted to know the station at which this occurred, station of the max, we'll call it m, station sub m, equals the station of the PVC, just plus that x value, and that gives us our station here. So in this case, the station of our maximum equals, we were given station PVC was 9382.16, working in distances, always good, plus our x value we just came up with up here, plus 570.00, and we perform that addition, we get 9952.16. So this is where we want to report then in stations, because we wanted to find at what station does the maximum of our curve occur. So that's equivalent, that's the symbol for equivalent, to station 99 plus 52.16. So this is what we would report. Okay? So, did all the math in pure numbers. At the end, if I needed to, I reported in a station. It's much easier. Okay. So what if we wanted to know the value or the elevation of that high point? So, elevation of high point. And keep changing terms on you. I use high point and max interchangeably. I do that a lot, but just know they're the same thing. That's the maximum of our curve. So let's find that. Since our high point occurs where x equals 570, all we have to do is plug that x value into our curve equation. So bring up our parabolic equation. I'm going to work in yellow. Y sub m for max equals y PVC plus G1 times x, the x value at our maximum, plus G2 minus G1 over 2L times the x value at our maximum squared. And I can write my givens down over here, where y PVC equals, and what was it, 41.76. These are just the givens in the beginning of the problem, okay? Y PVC equals 41.76. G1 equals 0.03, again represented as a decimal. G2 equals negative 0.02. And what else do we need? We need our L equals 950. And x sub m is the value we just found for the x value of that high point, the x value where that high point occurs. That's 570.00. All I have to do is take all of these and plug them into my equation. So, given that, we have y sub m equals, so I don't make a mistake, 41.76 plus 0.03 times 570.00 plus negative 0.02 minus 0.03 over 2 times 950. I'm going to erase those givens so I have room here and I don't try to squish. Since we already know those. If I worked on paper, I wouldn't have to do this. Finishing out, 950 times our x sub m squared. Okay, so if I do all that math, then I get 50.28. And as I figured above, that happens at station 99 plus 52.16. So there's no difficult math in here. A lot of times there's a lot of accounting. In engineering, any type of engineering, there's always going to be a lot of accounting. The key is to keep aware of where you are in the problem solving process, and solving in a stepwise fashion helps with that. And then keep your eye on the prize. What is it I'm trying to figure out? That's kind of the key to success to solving more convoluted problems. So this is an alternative way of working through the example problem posted on Canvas. And then there's an additional problem posted on Canvas that you can work through on your own. And with that and this video, you should be able to finish out the homework. Okay? So that will be all. Thanks.